Now here's a slide from the book, just going over these same properties. The only thing they add on is that these are continuous. There's no breaks in the graph as we go from the left to the right over its domain. All right, so now let's talk about transformations. This is, by the way, this would be decay. Remember how a second ago I showed you decay was a graph going down over time. It was decreasing. This is decreasing because the space is less than 1. This makes it decay because base is less than 1. Okay, so this will go down over from left to right. Not only that, this tells us it's been shifted, and this is on the what we'll call the inside. So since it's inside, it follows its horizontal because of HIVO, and it's also backwards. So this will be a shift left 1 unit. So when I look at the graph, I would have you can see that it's been shifted left 1. If you want to know exactly, you can look at any point, or you can go to the y-intercept. You see how this one is at 0, 1 like it should be. This graph hits at negative 1, 1 because it's been shifted left 1 unit. So let's try this one. Again, this is the same decay function. This time we have a flip horizontal. A horizontal flip would be flipping from the right to the left and left to the right. That, because it's a horizontal reflection, would be going over the y-axis, going from right to left, left to right. It's crossing over the y-axis. So this is a reflection over y-axis. Now, before I show you this, well, I'll go ahead and show you the graph. Here it is. Now notice it looks like it's now a growth rather than a decay. And here's why. And by the way, this doesn't change this point here because it's on the y-axis. Here's why. Anytime you have a negative power, so a base to a negative power is equal to the reciprocal of base to the positive power. Let me change it like this. Let's do to the plus power. Starting to write positive again. So what does that mean in our case? We have the base 1/2 to the power of negative x. That's going to be equal to the reciprocal, which is 2 over 1, to the power of positive x, which you could simplify that one more time and say this is equal to 2 to the power of x, and that would be growth. All right. Let's do another one here. This has a few different transformations. First, we have a reflection on the outside. So if it's on the outside, it's vertical. And if it's vertical, it means the top goes to the bottom goes to the top. Which axis are you flipping over? That would be over x-axis. This is a multiplication on the outside, so it's vertical. Anytime you multiply something by 2, it gets bigger. So it's a vertical stretch by factor 2. Let's look at the picture. And here, no, they didn't vertical stretch it. This graph is not correct. You see this point, how it's 0, 1? If the picture were correct, this would be shifted not into 0, negative 1 like it is. It would be 0, negative 2. So this picture is not correct. Let me give a better picture. All right, now I've got it updated. As you can see, this went from going to 0, 1 to 0, negative 2 because it's been stretched by a factor of 2. All values just get multiplied by that 2, and as well as being reflected. All right, and now you try this one.